A hurricane is Mother Nature's grandest but most ferocious weather machine.
A hurricane is two different things. If you're looking at it from above, from the satellite down, hurricane is a beautiful thing. It's a massive coil of clouds that is rotating, spinning like a top.
When I look at images of hurricanes, I go through so many emotions. As a scientist, as a meteorologist, I'm like, wow, this is fascinating. Look at this beautiful storm. But then the human side of me is saying, how can we make sure that people are evacuating, that people have somewhere to stay, that they have the money to feed their families once they leave their homes?
The hurricane on the ground, that's a completely different thing, because all of that rotation you really feel as incredibly severe winds. They can be up to 150 or more miles per hour. You can have up to 40 inches of rain. And the most deadly thing is that the updraft from the hurricane is actually pulling ocean swell up into it, and so it creates a storm surge up to 40 feet high.
And occasionally, when the storms hit at a little higher latitude, they can also spawn tornadoes in their fringe. So really the impacts are the wind, the storm surge, the heavy rainfall, and then occasionally severe weather that forms when they move inland.
I feel like I got a deeper appreciation for hurricanes when I moved to Galveston, Texas. That entire city, it's almost like the ghosts of the 1900 hurricane that are still there, because you see evidence of that storm, that particular famous storm that killed somewhere between 6,000 and 12,000 people. And so that is a very present, thing in the city, even to this day.
So that was a Category 4 storm that hit Galveston on September 8th. And there really was not a lot of information about what was happening in the Caribbean before this storm made landfall.
And the hurricane hit them totally unprepared, and thousands of people lost their lives, tremendous damage because it surprised everyone. With the onsets of satellites, that will never happen.
The first leap forward would have been being able to see the entire planet from space in the first place. Because prior to that, how would you know, for example, that a hurricane was coming? It would have been very difficult to know where it was coming, where it was going, how bad it was going to be.
So that's one of the dramatic impacts, is satellite data, sort of like your eyes in the sky to make sure that Mother Nature never can surprise you.
When I was a child, I loved playing with magnifying glasses because you can zoom in, and see so many fine details. And that's what we can do with the satellites that we have now, particularly the GOES-R series. We're getting 60 times more data now than what we were in the previous series.
The first satellites I worked with, the GOES-I through M, which were great satellites, but taking a picture of the globe every 25 minutes, the hurricanes would be like here, and then they're here, and then they're here. And it's not like you're losing track of them, but the difference between that and being able to see, oh, it's swerving, it's curling, oh, it's dying. We take a full disk picture of the entire hemisphere in 5 minutes, but we can also look at smaller areas, and you can scan that once every 30 seconds. You get to see, as the hurricane eye wall is forming, you can see that actually forming in real time. The Earth looks alive. It looks like a living thing.
So the polar orbiting satellites complement the geostationary. Since the geostationary are like 24,000 miles up, while they get great pictures, it's really hard to measure what is the state of the atmosphere from that distance. So the polar orbiting are basically flying a little over 500 miles up. And when you're at that altitude, you can sense what's in the atmosphere to a lot higher resolution. The JPSS satellite is really primary purpose is to take measurements of the temperature and moisture of the atmosphere to drive the weather forecast models.
Two things people always want to know about hurricanes are how strong is it and where's it going to hit. And microwave sounders can certainly help with both of those. The ability to see through clouds becomes really important. If you've ever seen a picture of a hurricane from space, mostly what you're seeing is clouds. And you can get a better weather forecast, a better prediction of how strong the hurricane is and where it's going to hit, which direction it's going to go, if you could see through those clouds and see the structure of the atmosphere, maybe even the ocean conditions underneath that. And so microwave sensors allow you to do that kind of thing.
As you've seen, when they do the hurricane forecasting, there's usually a cone of uncertainty they put in the path. We don't know exactly where it's going, but for the next 3 days or 5 days or 7 days, here's the cone that it could go in. But you don't want to overwarn, right? You don't want to have the whole East Coast running inland 100 miles because of a hurricane, potential hurricane. You'd like that as precise as you can, so that only the people who are really going to be affected have to do something. The improved sensors that we've been flying allow a better understanding of the core of that hurricane and allow the forecasters to better predict precisely where that hurricane is going to hit. And when they do that, then you can narrow and shrink that cone of uncertainty and give a better prediction.
We hope to continue to improve the ability to do track forecasting. That's gotten so much better over the past couple of decades. Our 5-day forecast is about as accurate as our 2-day forecast was only about 20 years ago.
And increasingly, people are listening to the forecasts that they get from meteorologists. They have increased confidence. They see the improvement in forecasts as it relates to hurricanes over the last couple of decades. And when a hurricane watch or hurricane warning goes into effect, people take notice and they take action. And that's really encouraging to see.